Hello, everyone. Thanks for joining us again in the session. It looks like it's working. Can you hear us all good at home and in the room? Yeah, perfect. Hi, Claudia. Thanks for joining, and I leave the floor to Emanuele.
Okay, so good morning. This morning we will talk about the status and the last development in the top reference ontology part of the OntoCommons ecosystem. So, as you may already well know, the OntoCommons ecosystem consists of a hierarchy of ontologies, set of tools and methodologies, and specification. This morning we will talk about the first part, so the hierarchy of networked ontologies. So the idea behind the OntoCommons project is to create a set of top-level ontologies that are aligned in order to implement practical pluralism so that it will be possible to share formalized knowledge belonging to specific top-level ontology community within framework belonging to different top-level ontologies. So the idea is to be inclusive, to reuse existing solution, avoid the risk of alienating communities, using available domain ontologies, allow multiple representation for the same problem we define as a pluralism, and minimizing the risk of clashing against already de facto standards or important actors that will pop up and propose new standards. So this will be done by proposing an alignment, and today we will speak about the alignment between top-level ontologies. The idea is that if you provide alignment between top-level ontologies, it will be much easier for mid-level or domain-level ontologies belonging to a particular top-level ontology community to be aligned or to share their knowledge in an easier way. So the objective of the Work Package 2, which is in charge about the development of this top reference ontology framework, are the development of course, this top reference ontology to define a framework for middle-level ontologies in terms of landscape analysis and methodology for alignments, and to provide the actual alignments between the top and the mid-level. So this morning we will talk about first about the top-level ontologies alignment, and I will leave the podium to Claudia that will present the work done in the last month in this topic. Francesco will show you the idea of bridge concepts and how they are used in order to facilitate the use of top-level ontologies. Arco will talk about the mid-level requirements framework, and in the end, I will show you the how-to-DL framework that we are trying to develop in order to host the alignment and the top-level ontologies in a computable language. So let's start with the Claudio presentation. Just page 5. Okay. 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 So Claudio.
Okay, thank you, Emanuele. Then next slide, please. Thank you. And I want to start just with a simple example. Let's suppose we wanted to represent the fact that John weighs 60 kilograms today. Then we have different modeling choices in order to represent this statement. Say we can introduce, for example, binary predicates, and let's say that John that is being 60 kilograms heavy, and this applies to John at T, as in the first example. Or we can consider temporal parts of John's, then is not John, but is John, the temporal part of John as T that weighs some 60 kilograms. Or we can also put time outside the domain of quantification, introducing some modal operators, for example, like in the third option in the first line. Or we can introduce inside the domain of quantification also properties like being 60 kilograms heavy, like in the second line of example, and then introduce a relation of weights between John and this property reified inside the domain and time t. Or we can apply, as in the first case, this to the temporal part of John, or we can put the time outside, as in the first case. But we can also have other kinds, different modeling perspectives. Like, for example, in the third line, we consider states as part of our entities in the domain of quantification, and then we say, okay, there is a state. This state is of a specific kind. Is a state of kind being 60 kilograms heavy, and there is a participation relation that links John with this state, and this state exists at time t. Or we can also, if we have 60 kilograms inside the domain of quantification, saying that this 60 kilograms property basically participate also to the state, as in the last option in the third line. And clearly, this is not exhaustive. We have other options. For example, we can introduce tropes and then say that it's not John that weighs 60 kilograms, but it's the weight of John that has a specific property, as, for example, this is done in Dolce with individual qualities, etc. And still, there are some lacking details. For example, I didn't made explicit what does it mean, John at t. What is the temporal part notion? The notion of temporal part we consider here. I did not make explicit which kind of time I'm assuming here is a time based on points, on intervals. Is linear, is branch, is discrete, is dense. It is primitive, or it is basically built on the top of some abstraction process, etc. Then, as you see, also for this simple example, there exists really several modeling choices with underlying different ontological commitments. And this is just relative to a very easy example. And clearly, we need to do this modeling choice for a lot of different kind of notion. And then some of them have interdependencies. Then this means that some modeling choices are compatible or incompatible with other modeling choices concerning different back connected aspect of the domain we are interested in. Then, next slide, please. Then, basically, what is a top-level ontology? Well, a top-level ontology, as far as I understand it, is just a sort of global picture, global and consistent picture of a wide domain of entities. And then the idea is that inside a top-level ontology, we put together a set of modeling choices that are consistent, one with the other, and then are able to express quite a general kind of knowledge, like, for example, what does it mean for an entity to change properties through time, what does it mean to persist through time, what does it mean to be identical to another identity, what is the structure of an entity, merological or topological or geometrical, etc. Okay. And this top-level ontology in general, okay, needs to be philosophically, also conceptually well-founded, and this ontological commitment or conceptual commitment need to be characterized in an explicit way. And then basically we rely on, for that, on a formal characterization of primitives considering the top level. And then if we have a quite good axiomatization, this basically limits the misusing or a misunderstanding of the primitives considering the top-level ontologies, and also is basically make the ontological commitment transparent and explicit inside the top level. And clearly here we can have two radical perspectives, let's say. Also, Emanuele already talked about that. And then on one side, we can say, okay, we need just to agree on one specific top-level ontology, sort of standard, de facto, or established, and then everybody needs to comply, let's say, with this top level. Or on the other side, we can say, okay, everybody can develop its own top level, and this is fine. Okay? Next slide, please, Emanuele. Then basically, as I see OntoCommons choose a sort of middle position. Okay, it's open to have a different kind of top level, and then it's based on a pluralistic approach. And this is basically what the ontology common ecosystem does. Basically, it allows the presence of an harmonization of different views, different perspectives. But at the same time, okay, it tries to include inside this top or middle reference ontology a possible small set of top levels, and these top levels needs to be carefully justified, documented, linked, and then this means that it's not just that everybody can develop its own top level without any justification. We need to justify, to document it in order to be included inside, let's say, the ecosystem. And this allows basically for three main advantages as I see them. And the first one is that this ecosystem basically is a good starting point for building new ontologies. Then both at the top level, at the middle level, but also the domain level. And then this, let's say, it's make the reusing and modularization easier. And then the fact that is an ecosystem, then do not just include top level ontology one with the other, but also try to link them, okay, to understand what are the difference between one top level and the other one. This is a crucial aspect, okay, in order to guarantee semantic integration and interoperability. Okay. But clearly it requires a quite rigorous comparison among the ontological choices done in the top or middle level or also domain level ontologies. And also it's basically increase the trust, and it's basically a community effort towards a sort of framework that allows us to develop, analyze, harmonize, integrating ontologies, and then also metadata standards. And basically it's very important to have a community of persons that, let's say, recognize itself around a sort of set of ontologies interlinked between them. Okay, so next slide, please. Then, if this pluralistic approach clearly, because top levels are not are linked one with the other, clearly requires the management of possibly partial mappings between top levels, also middle levels, also domain level ontology included in the ecosystem. Then in this we made some methodological assumption for the first order logic version of the top level ontologies. Then the first, and that's we try to follow this methodological assumption during the project, but we will see that some of them can be questioned, can also be, let's say, considered in a weaker perspective. Then the first assumption was basically that in order to understand what is the relation between these top level ontologies, we need to carefully understand them, to deeply understand them. And then in addition to axiom, we need also to take into account what is the documentation of the axiom, and try to understand what the axiom and the documentation suggest as possible mappings between different top level ontologies. For example, for the link between Buffo and Dolce, we can see, okay, the Buffo consider the continuance that are quite similar to the endurance and blah, blah, blah. And then we try to introduce formal maps and see if this basic initial hypothesis of similarity between that's continuant and endurance or continuant partout and temporary partout is justified or not by the mappings. And this is also a way of partially at least evaluate the maps, also with some problems. We will see something later. Then the second hypothesis is the fact that we try to import all the entities that the source ontologies talks about in the target ontologies, basically to maximize the coverage of the mapping, let's say, in some sense. This is something that is relatively that is motivated by the fact that basically in this way we can better understand what are the ontological disagreements, identify problematics, primitives, notion inside the ontology, but also in an applicative way means that everybody I have inside one ontology I can import in the other ontology. We will see that this in some cases is a little bit problematic. The last methodological assumption was more practical, let's say, because we started from the top level ontology based on first order logic. Then we consider the mappings also as first order logic definitions, just to have the language of axiomatization of the top level ontology, the languages of mappings to be aligned. But we will see that also this can be basically changed a little bit. Okay, next slide, please. Then just in order to better clarify what a mapping is from a formal perspective, let's suppose to consider the mappings from Dolce to Buffo. Then we have the two ontologies expressing first order logic, the Dolce ontology called the D, and the Buffo first order logic theory called the B. Then what is a Dolce to Buffo mapping? Then, well, we start from the Dolce first order logic theory, D, and we add inside this D, we extend this D with a set of definitions that are definition of the categories and the relation primitives category and primitives relation present in Buffo. And then we call this theory, the original Dolce extended with this full definition DB. And then we check which action of Buffo, the original theory, can be proved starting from this from Dolce extended with the definition of the categories and the relation of Buffo, basically. And this is, from a formal perspective, what a mapping between first order logic version of the top level ontologies is understood in the project. Clearly, this mapping process can be iterative, and then we can start from initial set of mappings, try to understand if there are some critical aspects that break surface or formal correspondences, and then eventually go back, change, revise the mappings, and then redo the analysis. This clearly can be done few times because, as we will see, the mapping process and the understanding of what critical aspect and are quite costly. And clearly, it's also possible to have alternative mappings that can be taken into account. And then there is the problem of evaluating these mappings. Okay, and we will talk something. I will say something later. Okay, next slide. Then the first phase of the project. In the first phase of the project, we focused on the Dolce Buffo mappings. In the second phase, we focused on the Dolce Emo mapping. And then the idea is that the Emo Buffo mappings are just mediated by means of Dolce. Okay, next slide. Then I started just to give a flavor of what does it mean to have a mapping, and I start with Dolce and Buffo. We start also from Dolce and Buffo mappings because even though Buffo has a realistic stance, while Dolce has more the cognitivist or common sense stance, they are quite similar. They are based on quite similar primitives. Like, for example, they have a distinction between occurrence and object events, let's say both of them have this distinction. They have a predicate of existence, parthood, participation, dependence. And then at the first sight, let's say they are quite similar. However, there is also a quite macro difference between them that basically, even though the basic primitives relation and the high-level distinction are quite similar, they differ when we go at lower levels, just because they focus on different aspects. Then basically, Buffo have a sort of focus a lot of the dimensionality of a spatial temporal region, or it adds some details about the structure of time. It also grounds the difference between bona fide and fiat continuance, etc. Dolce does not consider this kind of distinction. It's more focused on the distinction between agentivity and sociality for endurance, homomericity and cumulativity for endurance, comparativity for qualities. And in principle, this does not mean that there is some inconsistencies between Buffo and Dolce, But in principle, we can think that we can extend buffer with agentivity sociality, for example, and Dolce with the dimensionality of special temporal regions, or adding more details of structure of time. But these are not, these extensions are not present inside the original ontologies, and then we cannot basically consider at this level of the mapping. Then we need to focus on only on some notion and some categories that can be mapped one with the other, at least in principle. Okay, then next slide, please. Then for buffer, we focused then on the subset of classes that you see in red here, and then this is the taxonomy, the complete taxonomy of buffer, and basically focusing on the red one, and in partially also on the blue one, and the gray one has been not considered just because need some distinction, some notion that Dolce does not have at the current state. And next slide. Vice versa, also for Dolce, we consider just basically these red categories for the same reason. Okay, next slide. Then just another macro problem, okay, we found is that basically in buffer, universal are introduced inside the domain of quantification. Then we have properties, let's say, what a buffer called universal inside the domain of the quantification. The categories of the taxonomy of buffer are included in universals. And then there is also a temporary instance of relation, primitive temporary instance of primitive relation that links particulars to universal at a given time. Okay, for example, X with this notation here, we say that at time Tx is a continuant. In Dolce, the categories in the taxonomy are represented by unary predicates. And then there is, let's say, this is a quite different, almost meta representational choice, okay, that raise a problem because according to M2, this is a mistake, not M3, in principle, we need, if we start from buffer and we want to have a mapping into Dolce, we need basically to include all the universals of buffer inside Dolce, but there is no space in Dolce for this universal. At least at a very general point of view. Then the choice we have made is basically to avoid the introduction of universals inside the Dolce, and then we just say every time we have for a category in the taxonomy of buffer an instantiation of an entity for this category, then we translate in a formula of buffer that does not necessarily include universal inside this formula. Okay. Clearly, alternatively, we could also map universal to another possibilities that we just consider it a bit, but we not explore in detail, is the possibility to map a buffer universal to Dolce regions in the space regions, but this does not be explored in detail. Okay, next slide, please. Then just to give you an example of a mapping between Dolce and buffer, then we consider an example. Consider here an example that is relatively simple, at least superficially. Okay. Then basically, both there is an intuitive correspondence, let's say, between the continuance in buffer and the endurance in Dolce. Both are more based, let's say, much similar to objects. And then we have a part of the relation that with a temporal argument that in buffer is called a continuant part of relation and applies to continuance. And there is a similar relation in Dolce that is temporary part of the relation that applies to endurance. And then here you see basically what are the arguments, the restriction, the argument restriction of the two relation. And the first one applies to two continuum and to a temporal region, time region. And the second one, the one of temporary part of Dolce applies to endurance and time. Then it seems basically that these two relation can be quite easily mapped one on the other one. But if you carefully, let's say, consider, for example, what Buffo considered inside of the continuance, then you see that differently from Dolce, it includes inside the continuance also what we call special regions or space regions. I don't remember now exactly, and also some what qualities and kind of attributes, properties, etc., that in Dolce are not included inside the endurance. Then you need to basically, when you try to define what are the continuants of Buffo in terms of Dolce, you need also to include inside this continuum also qualities and spatial regions. And then when, because the continuum part of relation is defined as continuant, you need to take into account the fact that your temporal relation in Dolce is defined only on endurance, and then you need to extend it also to apply it to qualities and spatial region. And this is what does the definition in the third bullet, that basically say, okay, how I can define the continuum part of relations starting from Dolce? Well, this continuum part relation coincide with a temporary parthood when we have endurance. While for special regions is coincide with P, that is a different primitive relation in Dolce that applies only to regions. And while for qualities, we have a sort of temporal part among the endurance, the qualities therein. Okay, this is more a little bit technical. But the idea is that we do not just collapse the continuum part of Buffo to temporary part of Dolce. But we need, because in the continuants in Buffo are included also qualities and special regions of Dolce, we need to extend this relation in this way. Okay. Next slide, please. Then we have this mapping and check if some actions are that Buffo consider as satisfied or not. For example, Buffo has an axiom that the independent continuants that are not object aggregates, then a subclass, let's say, of continuants. Then for this subclass, the parthood is antisymmetric. It says that it's not possible that at a given time t, one thing is part of the other, but it is different. I mean, there is let's say x is part of y at t and y is part of x at t. It's not possible, implies that x and y are identical. Then basically it's not possible to coincide merological at a given time without being identical. Starting from the actions of Dolce and considering the definition we saw in the previous slide, these actions can be proven. Then basically in Dolce we have the possibility, for example, of having a sum of bricks and a wall, two different endurance that coincide with respect to the temporal part of the relation at a given time, but are different. Then what does it mean that? What is the conclusion we can have starting from this from discovering this fact? Okay. Then one can say, okay, it's not a problem of disagreement between Buffo and Dolce. Okay, it's more a problem of the link we provide, of the mapping we provide. Okay, and then we can basically say, okay, start to provide a new mapping. Okay, and then say, okay, continuum parthood is not as we defined previously, but needs basically to apply only to endurance that are not one part of the other one. Then we basically discard from this relation the fact that the bricks and wall are one part of the other one. Clearly, this also is a little bit counterintuitive from the point of view of Dolce, but basically solve this problem. That's in this case, the bricks are not part of the wall at time t, and the wall is not part of the bricks at time. One of the two directions cannot basically hold at time t, and then we solve the problem in this case. Or against, let's say, our hypothesis, we can say, okay, this is make evident that there is a clearly conception between Buffo and Dolce. One Dolce allows for co-extension, or especially colocalizes different entities, while Buffo does not allow for that. And then basically we need to rule out one of these one. Then basically, why Dolce assumes that there are two entities inside the domain, some of brick and wall that are different. Buffo does not accept these two entities, rule out one of the two. Probably the less basic one, then it would probably accept the sum of bricks, but it would rule out the wall. The problem is that in order to understand that, we need to understand what more basic is, and then this is not easy. But in principle, one could also, against our methodological assumption, rule out one of these two entities. Okay, yeah, this is just to see how difficult is the establishing of mappings, how difficult it is to understand what these mappings means and in which sense they are acceptable or not. Okay, next slide, please. Then in the second phase, we focus on the Dolce-Emo mappings, and Dolce and Emo are quite radically different. Okay, Emo has a physicalist stance, as Dolce, as we said, has a cognitivist or commonsensical, let's say, common sense stance, let's say. And in particular, then the mappings, yeah, we have two ontologies are quite far one way or the other, and then the mapping is more challenging in this case. It's especially challenging the mapping from Emo to Dolce, because basically Emo is based on only two primitives, partude and causation. And then the idea, if we need to reconstruct in Emo all the distinction of Dolce, we need to reconstruct all these distinction on the basis of only these two primitives of relation. And this is quite challenging. We will see that in some cases we rely also on some extension perspective of Emo, then just not just on the core of Emo that consider just part of the causation, but also on some of this extension. Okay, then the next slide, please. Then the first things we have done is to try to construct in a notion of time in Emo, because in Emo, as we said, we just have physical particles linked by the causation and partude. Then the question is it possible to introduce a notion of time inside Emo, starting from these two primitives relation? And this construction of time is a sort of strong precondition for the possibility of finding mapping between Emo and Dolce, because Dolce basically has a strong, time plays a really central and fundamental role inside Dolce. Then without time, the mappings would be really, really partial. And the construction is based on the intuition that the causation implies temporal precedence. Then this is the intuition we used in order to build the time inside Emo. And we will see that the construction is technically complex, difficult, because of some characteristic of Emo. Then for the nominalism, the fact that the causation is discrete and have a specific, and the causation network have a specific kind of structure that makes the construction time not simple, let's say. And also because we didn't find similar works in the literature too. Basically, there are some works that build the time from causation, but the framework in which this work has been done is completely different. Often this time, the causation is not discrete, and the idea is to build the time and also space and some geometrical aspect of them, and then it's quite different. There are also be some byproducts of the construction. Then basically we was able to abstract some kind of result. For example, a strategy or to simulate the transitive closure of a relation in first-order logic. Also, reusable ontology particle, reuse time and ontology extending mereology with a partial order in general, not just causation. That is a partial order plus additional constraint. And just to give you a flavor, okay, next slide, please. To how the construction of time works. Let's say you see here that there are already 6 different definitions, one used inside the other one to arrive to the notion of what a time is. And basically, the idea is, okay, I define a sort of precedence relations, causal precedence relations between macro objects, and then causation is defined just of atomic entities inside the MO. Then we need to extend sort of causation that assure that the first object precedes the second one, and then we use this kind of definition you see in the point 1. Then in the second point, we introduce a sort of temporal equivalence that basically is based on the fact that an entity is indistinguishable, 2 entities are indistinguishable with respect to this macro causal precedence. We introduce it at point 1. And at point 3, we introduce what a time is, and a time is a sort of maximal sums of temporal equivalent sums of quantity. Then we need macro causal precedence in order to define what temporal equivalence is, and we need temporal equivalence in order to define what a time is. Once we have times, next slide, please, we can define some relation between these times, for example, a precedence relation between times, and also a partude relation between times. Now one can wonder, okay, but in which sense this is time? Okay, and then next slide, please. In order to evaluate our construction of time, we checked that the temporal part of the relation defined between times and a precedence relation defined between times satisfy the minimal criteria that Van Benten lists among the one that are enough to define what a temporal structure is. Then basically the part with is an extension numerology closed under product, the precedence relation is a partial order, and there are other 3 properties satisfied by them, that is what is called a separatedness, monotonicity, and mode. Okay, that basically regulates the behavior between precedence and partude, basically. Okay, I don't enter into the details, but just to give you the idea of how we tried to validate the fact that this, what we obtain, is in some sense a notion of time. Clearly, even though our construction satisfies these minimal criteria, there are other things that are not satisfied. For example, they are not satisfied. The time we are able to build is not really standard. For example, is non-atomic in general, is non-linear in general, and there are extended simple. This means that there are atomic entities inside our domain that can exist at different times. Okay, and these characteristics basically complicate a range of related definition. Okay, for example, next slide.
Claudio, speaking
yes.
of, can you stay within the next 5 minutes, please? Thanks.
5 minutes?
Yes.
Okay, good. Okay, then I just provide here an idea, and then I go to the conclusions. Okay, then for endurance and perdurance distinction, then how is possible in EMO to define the Deutsche endurance and perdurance distinction? Then we follow the intuition that comes from David Lewis, a philosopher that is a sort of perdurance, that basically says that endurance have homogeneous temporal parts and perdurance have heterogeneous temporal parts. Okay. Then here we have clearly 3 difficulties. First, which notion of temporal part we do need to consider, and the fact that the time is not a standard time, and that in particular that is not linear, introduce some challenges here on the definition of temporal part. Then we explored basically 2 different possibilities of defining temporal slices. One that is more standard one, based on the standard definition, sort of generalization of the standard definition of temporal slice, and the other one is more, let's say, MO oriented. And then about homogeneity and heterogeneity, then basically we say that, okay, something is homogeneous with respect to what? With respect to property. Then if something is homogeneous with respect to properties, phi, okay, if it satisfies phi, and also not only x satisfies phi, but also all the temporal parts defined in the two different ways, define this phi. And then we call this dissective. While non-dissective, there is some of the temporal part that does not satisfy phi. And then we consider here the extension of MO, okay, to say, okay, this phi comes from this extension of MO, are the types considered inside the extension of MO. And then, next slide, please. We basically define what endurance and perdurance are on the basis of the fact that they are dissective or non-dissective with respect to the types introduced by the extension of M. Okay, this is technical just in order to understand what is the difficulty. Okay, next slide, please. Then just in order to give some final remarks, let's say, then it seems to me that in a sort of pluralistic approach where we want to make an ecosystem, then mappings are fundamental, play a fundamental role to guarantee the interoperability and the fact that to connect one with the other, all the possible ontology inside the ecosystem. And if we focus to top-level ontologies, but also I think for middle level and at least some of the domain-level ontologies, these are usually complex theory from the logical perspective, and they are based on different ontological commitment. And then mappings, as we have seen, I think I succeeded to illustrate the difficulties. Mappings are not trivial, and especially they require a deep understanding of the top-level ontology in order to be established, and in order to these mappings make sense for these top-level ontologies. And our methodological assumption, okay, while the first methodological assumption that basically say, okay, you need to consider documentation, and then just in order to deeply understanding the top-level ontology in order to develop mappings in addition to the axioms. The other two assumptions can be also basically partially relaxed. For example, one can think that instead of requiring that all the entities of one theory need to be included in the target ontology, we can think that we can also allow to map just a subset of the entities of the source ontology in the target ontology. And vice versa, we can also think to have a different kind of languages in order to express the mapping. For example, we can think to a sort of model-based mappings that can be added to capture complex theoretical construction of entities of one ontology in terms of the entities of the other one. Like, for example, in some cases, we see interval set of points or points as set of filters of intervals, vice versa. Then the study of the preservation of axioms offers a formal evaluation of mappings because we are able to see, okay, given these mappings, this is what is preserved of the original ontology. But it allows also to clarify and establish different similarity between top-level ontologies. However, as we have seen, okay, in some cases, one can put a little bit more on the mappings just in order to recover some action. Is this okay, or is it problematic? Basically, mappings themselves express ontological commitment, and this ontological commitment needs to be tuned with the ones of the source target ontology we consider, and then this makes the evaluation of mappings quite difficult and qualitative, basically, in nature. And the last point that I did not touch, I don't know if Emanuele will touch later or it's already touched in other talk, that the mappings, the first order logic mappings, we are able to find between ontologies can be used to conceptually and also formally ground also our mappings. Then when we have version of top-level ontology written in OWL instead of FOL, and then some of the mappings clearly cannot be expressed because of the explicitity of first order logic is higher than the one of OWL, but at least can be used to ground some more basic mappings between OWL, and we have done this, for example, for Buffo and Dolce, and we'll do that also for Emo and Dolce. Okay, thank you, Emanuele. I think.
Okay, thanks, Claudio. Since we started almost 30 minutes late, we will continue up to 11. We will do our best to keep it short. In the meantime, if there are any questions, please, Claudio, try to answer using the online chat. We will see if we have time at the end of the session to answer some questions live. So,
okay.
Thanks.
Since we are a bit late, I'll just give you a brief overview of what the bridge concepts are. They are one of the tools developed in the context of the by the OntoCommons consortium and part of the lot of OntoCommons methodology. Since it's a tool, we might want to start from what it is for. It can be considered on one end a dictionary for concept for ontology, and on the another end a universal adapter. On the first side, it should improve accessibility for domain experts and connect the OSS to standards and resources. It should tackle issues related to semantic indeterminacy and lack of documentation. So they have to be fair by design, and they should create reusable resources tailored for ontology usage. When it comes for the role as universal adapters, they have to be something like minimal pipelines, data pipelines. They should solve issues related to idiosyncrasies in formal semantic characterizations, make the most of the mappings, which we have just seen, and address issues related to scalability in aligning a plurality of ontologies. This is related only to projects like the OntoCommons, so we should start from there. Semantic alignments, we have seen, are difficult and time-consuming. Since they are difficult and time-consuming, if we consider one-to-one mappings, it is absolutely impossible to proceed, especially since given a large number of ontologies, with one-to-one mappings, the incrementation is exponential and not linear. So we developed the solution is to have an hub and spoke structure instead of one-to-one mappings. One idea could be that an ontology could play the role of the hub itself, but there are problems to do so. First, an ontology fits all cases. You can think maybe of a group of ontologies doing that, but even then there are political issues related to the universal adoption of one ontology for everything. Moreover, there are issues related to framework modularity. So, for instance, some stakeholders might not be interested in having ontologies which basically an entire group of ontology just to have an alignment. So the alternative we have developed is having just ontology entities, that is classes, and they employ them. They are standalone upon creation and lack a formal characterization, focusing instead on the informal characterization. This allows them to be ontology neutral, and that's also something we come back later to, because it's a way to make them more accessible to people which have never been introduced to the formal framework of a given ontology and the peculiar terminology. So this is a way it is bridge concepts are connected to a single ontology. Basically, we individuate superclasses and subclasses, and if possible, equivalent classes. There are also possible mediated connections, which are immediately follow from the one we found, and that reduces the number of bridge concepts that have to be created. Then again, we have to focus on the one offering the most informative connections. We have seen that touched upon yesterday in a presentation from IKEA, and basically we will touch it again in a few moments when I describe how they are selected. So how is the network established? Basically, a single bridge concept or a group of bridge concept is connected to different ontologies. And the ontologies can be at different levels, and basically you can connect an ontology at any level to the same bridge concept. That makes it possible to have a structure which is unified. Moreover, the alignment we have already seen act as a way to have formal constraints, which make us act as sensors if we are making mistakes in aligning the bridge concept to the ontologies. And moreover, we have some more checks from the consistency of the alignment given different bridge concepts. They act in a sort of zipper effect, and they play a double role, spreading reasoning downwards and establishing horizontal connection between ontologies. For instance, you have two middle level, domain level ontologies, you have a bridge concept, and you can share data between them, or you can have a bridge concept connecting a TLO and a DLO. In that case, you have reasoning spreading from the TLO most likely to the DLO. Okay, so we have seen these first features, and they can be employed to solve the other issues related to the first part of the first role of bridge concept. Here is how they do it. Basically, this is an example of how bridge concept connect to ontologies, spreading reasoning and establishing a connection horizontally. And let's move on, since we don't have much time. We have seen that alignments are complex. Each and every alignment requires careful examinations, and we have also core problems. For instance, for now, we have considered the possibility of alignments as if they were simple, but labels can be misleading. Different stakeholders employ the same terms in the different ways. Different stakeholders follow different non-compatible standard definitions, and documentation can be inadequate. So you basically have no idea how to connect certain classes. There might be categorical mistakes. Mistakes are obviously possible in ontologies, and the complete formalization of a concept is just an idea, which is never realized. So it's better to focus on the goal, which is achieve a desirable level of interoperability and improve industry by means of data sharing, instead of thinking to recreate metaphysics or logic or whatever. So let's focus on the role as concept dictionaries. As it has been said, we want to focus on the informal characterization for bridge concept, and it is most important to select the right candidates. Finally, usability is compromised by the lack of proper documentation and undeterminate characterization, which is reflected in issues related to interoperability and alignment. So here we want to select the second role of bridge concept to basically connect ontologies where it matters. They have to be tailored to fit stakeholders' desiderata and to be something that stakeholders can understand, a link to domain resources and golden standards. So they have to be fair by design. Moreover, to select bridge concept and have the best bridge concept, we decide to have a mixed approach focused on extrapolation and not simply to ask stakeholders which bridge concept they thought they would matter the most. Then again, that's most important, so we also consider that. So here is our workflow of how bridge concept candidate terms are selected. Basically, first we have a review of a similar concept or concept we think they might be similar in ontologies and glossaries. Then we develop the systematic approach via skimming algorithm to select only the concept which seem more likely to give the better connections. This is basic network science and graph theory, so nothing new there. And we have considered employing some automatic tools, automatic mapping tools in an ancillary role to improve the analysis. Then there is a second step of integration and analysis, validation, and then negotiation. Without getting into the details, here is the form bridge concept take when they are created. So here's a template. It is divided in a few parts for domain experts, ontology experts, and there are some really nice features to it. It acts as a guide in bridge concept engineering. It is inked on fairness. It is implementation ready. So basically, you can simply copy and paste the part you have written once you are done, and you can put them into the Protégé framework. Conceptual analysis is not what we are looking for. We want to be conceptual engineer in a Carnapian way. So we are basically taking a lesson from everyday communication, and we don't think that we have to reach a complete 100% alignment between people to understand each other. Basically, we just want to avoid friction where it matters. So again, in everyday communication, this is a standard, and when problems do arise, and they're usually solved by the same facts, by the simple fact that problems tend to be solved if they are real problems. So I will just give a brief overview of the parts of the template. First, there is a part dedicated to elucidation. Yes, sorry. We conceptualize the concept in a way which is ontology and ontologically neutral, or at least as ontologically neutral as possible, and surely ontology neutral in the sense that it is not dependent on any single ontology framework, applied ontology framework. The vocabulary is designed for NMBP ontologies. The elucidation itself is divided into two parts. One regarding core traits, which should be understood by domain experts, and the other to avoid explicit ambiguities, for instance, that are relevant for ontology and ontological use. So this is an example of an elucidation, but we don't have time to go over in that. Just to give an example, it's for Atom. Once we have the elucidation, we provide also in the template the domain resources which were employed, and a discussion of how the elucidation provided connects to the resources. In this way, everything is explicit, and if a domain expert wants to align itself or understand better how we are making our bridge concepts, they can do so. Second step after the bridge concept is engineered is to align them. Basically, we provide the top superclasses, the subclasses we have chosen from the specific target ontologies, and we provide an explicit description of the reasoning behind the mapping. This is all documented and can be brought into the Protégé environment directly. So to sum up, this can also be a way, bridge concepts can also be a way to create new ontologies, basically focusing on this new vocabulary or something like a vocabulary which is provided. And yeah, these are just, I leave the word to Arco, which will provide more info on how the bridge concepts are connected in the lot for OntoCommons methodology. Thanks for your attention.
Excellent. Thank you, Francesco. It makes my job real easy to make a segue on. Okay. So now we have this introduction of the bridge concept. Theoretically, I want to show that how this bridge concept is really, practically used. So just to reiterate, you have already seen this ontology stack of OntoCommons from TRO to the domain level ontology. Bridge concept resides, so its home is at the mid level and also at the domain level, kind of at the domain reference level, you can say. So they are really useful in aligning two different ontologies, but at the same time, you can link these mid-level ontologies to the top-level ontologies, or say the domain-level ontologies to some upper-level ontology. Now, to do that, we need to have a structure, and that structure looks like this, a little bit complicated, but then it tells you like how these ontologies are kind of stacked from the top level to the bottom level. And you can see in the middle, we have on the right-hand side, we have these bridge concepts, and they are just concept. And I would like to add just a couple of points to what Francesco said, that this bridge concept's purpose is to align the concept of different existing ontologies. So when you are using the ontology, you will always use the existing ontologies. It is not advisable that you start using this bridge concept for creating your taxonomy or say like asserting your instances. But then this bridge concept actually helps you in say connecting two different ontologies. As for example, you can see that this IOF core and the KB, two different mid-level ontology has been connected by this bridge concept, and also they are connected to the top level, on top level ontologies. And of course, the top level ontology having their mapping among each other has this like complete aligned framework, and it let you to crosswalk between ontologies. Now, for the practical development, we have a GitHub repository, which Emanuele will introduce later in detail, but then it has a folder specially dedicated for this mid-level, mid-reference ontology related artifacts. And those artifacts, for example, will have this bridge concept templates, what Francesco just introduced, and also the MLO ontologies, which we are currently taking into consideration for mapping, and also the MLO mapping, which we are expressing in the, in the OWL format. Of course, the template will help you to create the conceptualization, but you need to, in the end, encode it in the OWL. So if you encode it in the OWL, this is one of the examples. This is how the bridge concept for a bridge concept called equipment looks like. And it's a very important bridge concept because many ontologies have this similar concept like say machine, device, tools, etc., etc. And you can see that we have this bridge concept equipment. We have linked the related concept from say Saref ontology, from IOF core, and then they are linked to this bridge concept. And this is another example for say this concept called measurement. Now, I want to show that how this bridge concept actually helps you to make your data flow from one ontology to another. So this is the real data interoperability, what we are talking about. So for example, say if you have your data, some data modeled with IOF core, some data model with Saref, and then they both have, say, for example, here the example is about a temperature sensor. You can create this mapping between this concept, but the mapping will be validated by this blue colored bridge concept. And then any instance, say, for example, a data entity which is modeled under Saref can be automatically asserted by using a reasoner under the IOF code. So in this way, if two different parties are using two different ontologies to model their data, this bridge concept and the whole alignment framework can help you to flow the data from, exchange the data from one party to another. And also, then there is another benefit that it also helps you to prevent the misalignment. Say, for example, some ontologies you are trying to map, underline, say, for example, Saref, they are not very axiomatically rigorous. So there is a concept, say, for example, measurement, and then you may think, okay, it is a process, so I will map it to IOF, say, measurement process. But then it is not, because it is an information, what Saref talks about, what Saref wants to express it. So if you do that mistake, then because this bridge concept has this alignment on top of these concepts, the reasoner will give you the error that, okay, you cannot map it to the process because it is an information, it is not a process. So there is a complete tutorial available on this. These are some of the snippet from that tutorial in the YouTube, in the OntoCommons channel. Now, very quickly going to some of the other work in the mid-level ontology, we are also trying to we are also trying to come up with a detailed technical principle, kind of like a normative and prescriptive, guide for developing a good ontology. So it includes like, some of this prescription we gathered from different sources. For example, Industrial Ontology Foundry, FIBO, and then Siemens Technical Guideline, etc., etc. And then, so what it contains, most importantly, the IRI convention, that how do you form your IRI? So there is a detailed grammar for that. Also, there is a detailed guide of how to write good metadata. What should be the good set of metadata you should use to annotate your class or properties. And so we also have a very kind of flexible, but then also, kind of rigorous rule. In a sense, like how should you use this annotation to define and then put different explanation to your classes. And this looks like that. This is one of the example which shows that if you rigorously make your ontology, this should look like this, well documented and using all the annotations properly. So not going into the other parts of the technical principle, but then there are many different topics in there. Now, lastly, there is one recommendation from us that, okay, so all of this, ontology, harmonized ontology stack, what we are, listing, about from the TRO to MRO, what is the use of it? The suggestion from, or the recommendation from OntoCommons is that in your ontology engineering methodology, you have to reuse ontology. For sure, this is already recommended by linked open term methodology, which is the ontology engineering methodology from OntoCommons. But then when we say reuse, what we say is that reuse from this ontology stack, that, okay, you have to use one of the MLO or TRO, which are in the, already aligned through the bridge concept and the other methods. But then, of course, it is kind of a little bit hard to understand and then, get everything in your ontology stack. So, of course, we are working on some kind of tool which will make your life a little bit easier, which is under development, but it will be visual, and then it's some click of a button, and you can download the ontology stack, which you will require to develop your domain level or application level ontology. So I'll stop here and then let Emanuele continue on the next one.
Thank you, Arco. I will be very brief. As you have seen, especially from the Claudio presentation, the ambition of this work package is really high, and the work is done also at a really high level. However, we would like to keep all of this work into a form that can be also computable, so usable from actual existing technologies that take advantage of the semantic web standard. So our idea is to put everything we've done, bridge concept, top level ontologies and alignment, into our framework that will be hosted and publicly available on GitHub. There is already a beta version of this, an incomplete beta version of this top reference framework published, but by the end of July, we expect to have at least a first usable version that will be then further updated in the subsequent month. So that's the idea. So this is exactly how this idea of top reference ontology is taking shape as a set of ontology modules that are interdependent and including the alignment. So that's and also protege ready in order for people to easy access the accompanying document. So that's it for the top reference ontology, and thank you for your attention, and sorry for being a bit late. I don't know if you have time for questions, because it's already past 11.
Hi, Roberto. You can unmute yourself.
Okay, why there are only these ontologies? Yeah, because of resources, because of the fact that we asked support for as many community as possible, and of course the environment is open. Actually, we had active support only from I would say EMMO and Dolce community. Meaning that the developer of these ontologies has been fully committed to this alignment. So it was a question of resources and availability of ontology developers to contribute to this type of alignment. However, the framework is free and open, and so it will be possible in the future for other top-level ontology developers to commit and to ask to commit their top-level ontologies and potential alignment to the OntoCommons framework.
Thank you, Emanuele. Any questions from the room or in the chat or from home? And Roberto, if you have any comments, feel free. We invited you on stage so you can unmute yourself. Okay. If not, we can still have, Hedy.
I have a question to Barry Smith.
A question?
To Barry Smith.
To Barry Smith.
Yes.
I'll try to repeat for the people.
Claudio presented the effort on the alignment between Buffo and Dolce Emo. And what do you think regarding possible alignment between Emo and Buffo?
Okay, so I'll repeat for the people at home. He's asking Barry Smith about his opinion on the alignment between Emo and, I couldn't hear, and Buffo.
I would think it would be a very good idea. I'm not sure about general alignment, so during part of what just happened, I felt as if I was in a community of religious people who were wondering how to proselytize their beliefs to make the world better. And they decided before they could do that, they had to find a way of translating the Bible and the Tibetan Book of the Dead into one single profitable religion. And that probably is not a good way of using religion to improve the world. But that's just my impression.
Barry, are you claiming that Buffo is a religion?
No, I was thinking of the Tibetan Book of the Dead.
Yeah. So Buffo was it?
I said it would be a bit like not doing any real religious work until you've taken two big religious documents and found a way of mapping between the two of them. That's not the way to do good religious work, I thought.
Okay.
Well, we can categorize us as a syncretist, I think.
Okay. Okay. So unless there are any other comments with a bit of comments and questions, I'm going to close this session for the moment. We are meeting here in 10 minutes, I think, Hedy, right? Yeah. 10 minutes. Okay. And so the people also can have a short break, and I invite you at home also to take a break and coffee, and we'll meet in the next session, which you can access also from the view schedule. There's going to be no parallel session in this next slot, so it's only one. And okay, I'll close this one. Thank you all. See you later.